Dia Yevacharja. Hello everyone, you're very welcome. This is a Raleigh Wisp moped, originally built in Ireland in 1967. But that's not where this story begins. The story actually begins in the 1930s, when the Raleigh Bicycle Company, based in Nottingham in the UK, established a bicycle manufacturing base in Ireland to provide bicycles for the Irish market. This was not an unusual practice for manufacturers in those days, as it helped to avoid paying import duty. For several decades, this old building was the Raleigh Bicycle Factory here in Dublin. Bicycles are no longer manufactured here, but it's nice to see the place is still standing. In 1973, Ireland entered the EEC. Thanks to the common market, such local manufacturing arrangements were no longer necessary. But that was not before a full range of rally bikes were built for the Irish market. And this little moped was one of those. When I found this Raleigh Wisp, it was about to be scrapped. Although it looked nice from afar, it was far from nice. Every centimetre of the bike was ruined. The engine was completely dead and had not run in decades. But when I discovered that the bike was manufactured in Ireland, I thought, this is worth saving. But that needs to be done in nauseating detail. To get a good look at everything, the first thing I did was a full strip. Not me, the bike. The frame was in a sorry state. The centre stand had broken off many years ago, and these cracks needed attention before we went any further. A small design flaw of these bikes is the manner in which the centre stand is welded on top of the frame tubes. When the bike sits on its stand, any weight pulls the stand bracket away from the frame, weakening the joint. By modifying the stand slightly and then welding it underneath the tube, I made a joint that would always be under compression and therefore much stronger. To make full use of the Raleigh Wisp's 1.5 brake horsepower, I made the new bracket as aerodynamic as possible. Before fitting it, those frame cracks we saw earlier were welded up. Welding thin metal can require a little patience. Before the frame could be painted, some other bodywork items were taken care of, which was quite therapeutic at times. These also included removing rust from the interior of the fuel tank. For this job, pebbles serve as a useful abrasive. There is really no dignified way of doing this. The tank was then sealed with an ethanol-resistant resin. The chrome items on this bike are a very important feature. They were utterly rotten. Some long days of metal polishing were put in at this stage to prepare for rechroming. Time to take a look at this dead engine. This is the original motor for this bike. It would have been easier to swap it for a new engine, but as always, my main focus is repair, not replacement. No matter how many horrors are lurking inside. Off with the clutch first, and then the carburetor. The carburetor mixes fuel and air in the correct ratio for combustion and also allows us to control engine speed via the throttle, but it needs to be spotlessly clean in order to work correctly. Unlike this. Ultrasonic cleaners do an excellent job of cleaning inaccessible areas, but the sound they make is not easy on the ears. A good cleaning reveals the carburetor was actually manufactured in October 1965, although now it looks like new. Some heat, penetrating fluid, and a dead blow hammer allow the cylinder head to be removed. The inside of every engine tells a story. The piston rings are stuck inside their grooves. This is most likely due to the use of a low-grade or incorrect type of oil. This is also indicated by the heavy carbon deposits on the piston crown. The forensic journey continues inside the cylinder. Here we can see that debris has caused the piston to gouge the cylinder wall. Although the smooth mirror finish looks nice, it actually indicates excessive wear. But the really sinister parts of this investigation are these blisters here on the cylinder wall. This is caused by corrosion behind the hard chrome cylinder coating. This cannot be simply ground or sanded away, as it will just come back. Such discoveries do not bode well. This was probably the low point of the restoration for me. I really wanted to save this engine. Anyway, on with the rest of the engine disassembly. The crankcase halves can only be separated by heating them so that they expand and can be slid off the main bearings. While still hot, it is best to prise out the two old oil seals, as it's a good opportunity to fit fresh ones. The main bearings on one side were excessively worn and on the other side seized. This and the rusted bearing surfaces tell a story of a lack of lubrication. The connecting rod big end bearing lives inside here. Due to some miracle, it was the only part of the bike that was still working. This was the turning point. From here on, things would begin to go back together. Starting with the engine rebuild. I had the crankcase halves and other aluminium engine parts vapor blasted. Vapor blasting not only cleans but also leaves the surfaces more resistant to corrosion in future. Better than new. I made this little metal bridge to hold the crankshaft while I fitted the main bearings. To fit the main bearings, I waited until my wife wasn't looking, and then I cooled the shaft in the freezer to make it contract. While at the same time heating the bearings to over 220 degrees Celsius to make them expand. By doing so, the bearings can be gently tapped into place. When at room temperature, the bearings and shaft form a really tight fit and will not budge. Here I'm priming the bearings with the same oil I will use in the Wisp's engine. I really don't know why I chose a strawberry scented oil. It seemed a good idea at the time, but everything now smells like jammy donuts. Then I made this wooden block to stabilise the engine while I fitted the crankcase halves. The crankcases also must be heated to make them expand so they can be slid onto the new main bearings. While hot, I popped in the new oil seals before fitting the crankshaft. Here they are in place. The shaft should just drop in. The gaskets in this engine are made from paper. I'm impregnating the gasket with engine oil before fitting. The same process is used to fit the other crankcase half. I'm trimming excess gasket paper here, but taking care not to scratch the mating surfaces. I had all the original fasteners re-zinc plated. They took a long time to prepare, but I want to keep everything original. On goes the piston, retained by the piston circlips. Another paper gasket seals the crankcase to the cylinder base. If we had a cylinder, that is. We have a cylinder head, but without the bit in the middle, we don't have an engine. But then, one day, An Post left something at my front door. The original cylinder was saved. The cylinder bore had been re-sleeved and a new cylinder wall actually pressed into place. The finish is spectacular. This engine is now as good as new and ready for another 50 years. By compressing the piston rings with one hand, the cylinder can be gently pushed into place. The technique just requires a little bit of finger yoga. Unfortunately, after assembly, the connecting rod was striking the base of the new cylinder lining. Some remedial action was required. These new inlet manifold studs are made from titanium. The weight saving could make all the difference in a race. Peened aluminium, stainless steel and titanium. This will never rust again, as it did before. Before fitting the clutch, I purged any old lubricants and debris from the crankshaft. The other side of the engine generates electrical power for the ignition and vehicle lighting. The housing is sealed to the crankcase with this gasket, which needs to be replaced. But this gasket is no longer available. So I just made a new one. And then the engine build was complete. Then it was time to refurbish some other items before reassembly. The Raleigh Wisp does not have a suspension system, so seat comfort is important. This seat, however, was missing a very important component. The spring. I tried to reuse items as much as I can before disposing of them. The junk main bearings from the engine rebuild did a great job of holding the spring in place during welding. The flat end surfaces on this spring spread the weight evenly. This is a replacement spring I found online, as the original was missing. Turned out to be a really nice fit. Now, I wouldn't be one for those cheesy YouTube transitions, but maybe just once. And that completes our protection of the bottom line. Let's lace up some wheels. These are stainless steel spokes and are slightly thicker than the originals, which were in poor condition and needed replacement. The first spoke in wheel building is called the key spoke, and it is important as it decides the angle for all remaining spokes. If we get that angle wrong, we can end up with a spoke hitting the inflation valve. The original spoke pattern was reproduced exactly. This is a necessity in order to fit the sprocket. Tyres were fitted using a little talcum powder, a lot of silicone oil lubricant, and without using tyre levers in order to protect the fresh chrome finish. We can see here the necessity of reproducing the original spoke pattern. The small stature of this moped needed a stronger colour than the original one. This is a period appropriate shade that adds a nice contrast to the other hues on this bike. This new colour helps to declutter the overall look of the bike and accents certain details such as the polished chrome features. This nylon sleeve ensures a nice smooth pivot for the centre stand. A little grease, smeared on the bearing races, is a nice trick to prevent ball bearings from escaping during assembly. Now let's test the ignition system. I'm turning over the engine by hand to see if we can generate a spark. A spark means we can go, and these NOS or new old stock brake cables will help us to stop. A little bit of rewiring to get the lights working and the Wisp was ready for the road. The only question though, will it start? Because this rebuilt engine is effectively brand new, it needed to be run in once again. I ran 9 cycles of cold start, warm up and cool down. Each cycle progressively increasing the power and duration of the run until the engine was fully ready. With the running in complete, the final touches of the project could take place. These moments in a restoration are a great pleasure. The very last thing to be done was the ceremonial fitting of the final chrome panels, and the restoration of this Raleigh Wisp was finished. This little moped is great fun. The engine feels willing and enthusiastic, And for a frame that has no suspension, the ride is actually smoother than you might think. This is fortunate because this bike will not get you anywhere quickly. That said, it has a huge grin factor and is more about the journey than the destination. For me, the most interesting part of this restoration was the realisation of just how easy on our environment old bikes like this actually are. The high quality steel tubing of which the frame is made would have originated in Nottingham in the UK, meaning a short journey across the Irish Sea to Dublin, where it was locally manufactured for a local market. Hardly a global footprint. And as we've seen in this series, many of the components on this bike are made from renewable materials such as card, cork, natural rubber and paper. Spare parts literally grow on trees. Plus, there's no plastic on this little bike to pollute the planet long after it's gone. The emissions of this bike are also worth a mention. Yes, it is an old two-smoke, and yes, it will leave a scented trail of nostalgia wherever it goes. But when we do the figures, this engine averages 58 grams of CO2 per kilometre, which is not bad considering an electric car in Ireland today produces 78 grams of CO2 per kilometre. This Wisp actually produces far less carbon than an e-scooter or an e-bike. And on the subject of electric vehicles, for every tonne of the rare earth elements produced for lithium batteries, 75 tonnes of acid waste is produced and 1 tonne of radioactive waste is produced. This little Raleigh doesn't even have a battery. Many older vehicles were actually far better for our environment than their modern equivalent, and yet we're throwing them away. Well, I'm going to keep rebuilding them, and if you'd like to join me, please subscribe to TechShebean, and together we can share the skills necessary to protect our motoring heritage and our environment too. Until then, slán go fóill.